Hello everyone, my name is Kasula Sumanth and I am second year undergraduate student of KAKATIYA Institute of Technology and Science, Warangal. I made this video as a part of my assignment on machine learning using Python course that is offered by Skyfi Labs. My project is on price prediction of the Boston houses. I use the tutorials given by Skyfi Labs to complete my project. The content delivery in the tutorials is very good and easy to understand. In order to complete my project, I need to import some libraries such as NumPy, Pandas, Matplotlib, Matplotlib.animation, sklearn. The use of NumPy is that the NumPy is used to handle multidimensional arrays, easy to do vectorized operation. A vectorized operation is done on vector data type, and we use Pandas to load data into data frame object. Pandas provide easy to use data structure for data analysis, and the data which is required for Boston housing is imported from sklearn. Step 1 is data pre-processing. So I loaded the Boston house data set into the variable named Boston, and I printed the description of the Boston housing dataset. The description is as below. The description contains 506 instances, and that means it contains 506 data points, and each data point contains 13 features such as CRIM, ZN, index, such as. Next, I loaded the features into a variable features using Panda data frame, and I printed the features. For example, I took one of the feature and printed. Next, as I require target, I created a variable target and loaded the target data into the target variable using Panda data frame, and I printed the target. For checking the target variable, that how it works, I printed the maximum and minimum values of the target. Next, I have concatenated the features and target into a data frame object, single data frame object with axis equal to 1. That means the target is added to the features list. Next, description is the first step we need to do after importing the data to get the basic insights. It provides a bird view for us. Next, we find the correlation of the features between the features and between the target. So I have founded the correlation and found that by this bar graph that LSTAT has the maximum correlation with the target value. So next, we have founded the maximum correlation. Next step is preparation of data for linear regression. So I have loaded LSTAT values into X and target values into Y. I have printed Y values before normalization. The goal of normalization of data is to change the values such that after the transformation, all the values lie under a common scale. See, I have printed the values after normalization using min-max scalar, and I have got the values between 0 to 1. These all values come under a common scale. Now step 2 is defining error function, and I have defined the function. Now step 3 is splitting the data. The train test split function will split the data into training dataset and testing dataset. And next we will define the update function. It will update the weights at every step. And next, defining the error function, it will update the cost function value. And next we will define the grade descent function. The grade descent function applies gradient descent on the cost function and returns best fit values for M and C. And I have initialized the M, C and learning rate, iterations and threshold values. Next, step 4 is visualization of the training model, that is error visualization, and I have plotted the graph below as shown. Next is plotting the figure and axis graph. See here, the animation is set to true so that the line gets animated. Next is defining the initialization function. This initialization function will not contain any parameter, and this returns the line object. Next is defining the update frame function. This will update the M and C values and return the line object each and every time. This is the graph of gradient descent function. And the last step, that is step 5, is prediction. I have calculated the mean squared error between test values and predicted values and obtained the value as given below. And next, I have loaded the data frame into the P variable of X test, Y test and predicted values. you can see the columns as x target y and predicted y. These are the normalized values. Next, I need to renormalize the values so that I can compare them with the actual values. So I have renormalized the values using inverse transform function and printed the data frame, and you can see the x target y and predicted y values here. Thank you.